Hi, in this video we will learn about how to write an equation for a line in R2. So far we have learned about equations for lines and planes in R3, and we have seen that, well, you need different kind of information and there are this list of forms that you can write equations in. Well, kind of similar story is true for lines in R2, but you will see very soon that, well, there are more possibilities, more forms for equations in R2. Well, let's us just start with what are these forms. So to write an equation for a line in R2, we need always, this is a minimum thing, we need two pieces. And these two pieces can come in different forms. One is that a point, let's say P, while here it is R2, so it will have only two components, and a parallel vector. V1, V2 are given. Well, in that case, similar to the lines in R2, we can write an equation in point parallel form. And also we can write parametric form. Well, what was point parallel form? Point parallel is, well, we have xt equals to p, the vector p plus t times v. Well, it is the same thing, but the only difference is that here we have only two components for vectors and two coordinates for the points. So that's exactly the same thing, and you have it like that. And parametric form also is the same, but this time you have only two coordinates, and so two equations, p1 plus tv1 and p2 plus tv2. Well, this happened for the lines also. There were another third option, which was 2 points, P and Q are given. In that case, the form we had for the lines was called 2-point form. And how was it? So xt in that case also is equal to 1 minus t times p plus t times q. Well, let me just write it in terms of the coordinates. So this is 1 minus t, p1, p2, plus t times q1 and q2. Well, these are exactly what we had, what kind of options we had for a line, two lines in R3. So far, that's exactly the same thing. What happens next, well, is a little bit strange, because we can write an equation for a line in R2 if we have a point and a normal vector, a vector which is perpendicular to all directed line segments on the line, normal vector n, which is n1, n2. Well, in this case, these were the options that we had for planes on R2. So in that case, we have point normal form. Also, we have standard form. Well, point normal form was n dot x minus p equals to 0. Well, it is exactly same thing with one difference that here we have only two components and x is just xy. So xy p1 p2 equals to 0. How about the standard form? Well, remember standard form is of this form, ax plus by equals to c. So let me put it here. But how did we find it? This is simplification or expanding of this. N dot x equals to n dot p, which gives us n1x plus n2y equals to n1 p1 plus n2 p2. As you can see, these last two options is only possible for planes in R3. So lines in R2 are like lines in R3 and planes in R3. So it has 5 possibilities depending on what kind of information we have. If we have parallel vector and a point, we have exactly same possibilities that we had for lines in R3. But if we have a vector, normal vector, and a point, we have possibilities of point normal form and standard form, the forms that were available only for planes in R3. Okay, let's do an example for this before we end the video. So example, find equations in all 5 form for the line in R2, which is through 1 and -1, and it is perpendicular to vector 2 and 3. Okay, the information given is that we have a point 1 and -1, and we have a normal vector 2 and 3. Well, in this case, right away we can write point normal form. Normal form, which is, well, n dot x minus p equals to 0. We can also write the standard form, which is, well, you start with n dot x equals to n dot p, gives us 2, 3 dot xy equals to 2, 3 dot 1 and -1. This gives us 2x plus 3y equals to 2 minus 3. So the standard form is 2x plus 3y equals to -1. Well, very nice. But how I can now find a parallel vector? Because you see, to find these two forms up here, I need a parallel vector. Well, that is something very special for R2. In R2, this is a fact. Well, the vector, so if you have a b vector, you can find a vector which is perpendicular to this just by doing this operation. Is perpendicular orthogonal to, just do this operation. Switch the components, so b a, and make one of them negative, either this, or you can do b minus a. Switch, make one of them negative, multiply one of them by negative. Vector this is perpendicular to that. Why? Well, remember the orthogonality test. AB dot minus BA is going to be minus AB plus AB, which is 0. That's why. So this is a fact we can use here. How we can use it? Well, let me just tell you. We know that we know 1, 2, 3 is perp to the line. Yes, this is n. And we also know that v is parallel to the line, the parallel vector. Yes, so we have two vectors. One is perpendicular to the line, the other one is parallel to that line. That means that, let me call this one n, as we have n as a result is going to be perpendicular to v. Well, that's very easy to see when you have a line and a vector which is parallel to that v, and a vector which is perpendicular to that n, then these two guys are also perpendicular to each other. In other words, we can take any vector which is perpendicular to n as our parallel vector. Very nice. So in other words, now I know that I can combine the fact with this result that we have here, and I can say that v can be either switch the components 3, 2, make one of them negative, or we can do the other one. v can be 3, negative 2. Remember, switch the components and multiply one of them by negative. Okay, by having v in hand, we have a point and we have a parallel vector. Point parallel form can be found. So point parallel form in this case is xt equals to p, which is 1 and negative 1, plus tv. And similar to that, parametric equation parametric form. This will be x at t is equal p1 plus t v1. This goes there, this goes here. And yt is p2 plus t v2. So xt is equal to negative 3t plus 1. Yt is equal to 2t minus 1. Well, there is one more left, that is 2-point form. So for finding 2-point form, we need another point. Remember, we did in some example for R3 Q, you can use the point parallel form and set the Q's, the point given by x at 1. So Q is x at 1, which is 1 and negative 1 plus 1 times negative 3 and 2. That gives us 1 minus 3 is negative 2. Negative 1 plus 2 is 1. So we have Q, we have P. So xt is going to be 1 minus t times P, which is 1 and negative 1, plus t times Q, which is negative 1 and 1. So these are all forms for one line. So you have to know how to find these forms, what kind of information you need, and how you can go from one to the other one.